We're going to look at solving recurrence relations to find the values of A and B. So in some problems, you may be given several values of U and asked to find the values of A and B. This can be done easily by solving equations simultaneously. So for example, a recurrence relation is defined by un plus 1 equals A times un plus B. If u1 equals 4, u2 equals 3.6, and u3 equals 2.04, we want to find the values of A and B. So to start off, we need to think about how these recurrence relations are formed. So in order to get our next term, u1, starting at the beginning, we would take our A value and multiply it by our initial term, which would be u0. Then we'd add on B. Then to get u2, so the next term, we take our current term and multiply it by A, so our current term being the first one, so u1, and add on B. To get the third term, u3, do the same thing. We take A and we multiply it by our current term, u2, and we'd add B. And we'd keep going. So when we look at this, if we put in our values here, so we have u1, right, and u0. Well, given the information, we don't actually have u0, so this just helps us get an idea of where it is, but we're not going to really use this equation. But we're going to use these two equations here because we have these values. So let's substitute in the numbers. So u2 we have is 3.6, which is equal to A times u1 of 4 plus B. Again, we don't know A and B. u3 is 2.04 equals A times u2, which is 3.6 plus B. Simplifying this up, 3.6 equals 4A plus B, and 2.04 equals 3.6A plus B. So here we formed two recurrence relations. We have two unknowns, A and B in both, and we can solve them simultaneously. Now whichever simultaneous method you want to use, which is fine, I'm going to start this video off with substitution. I'm going to equate them, or substitution if you wish, and then I'll also show you how you can use elimination. So to start, I'm going to equate these two. So I'm going to take the first equation and rearrange it to make it equal to B. So B equals 3.6 minus 4A. I'm going to take my second equation and rearrange it to make it equal B. So B equals 2.04 minus 3.6A. Now that I've done this, I can make them both equal to each other, or I can substitute my B in for B. So I will say 3.6 minus 4A is equal to 2.04 minus 3.6A, and I'll solve. So I'm going to add 4A to both sides. I'm going to subtract 2.04 from each side. And when I do this, here 3.6 minus 2.04 gives me 1.56. 4A minus 4A is 0. 2.04 minus 2.04 is 0. And then 4A minus 3.6 gives me 0.4A. Divide both sides, and A will be 3.9. Now that I have A as being 3.9, I can then substitute in my value of A into one of these equations, or I can do one of these. So here, I'll take the 3.6, because they're all the same equation rearranged. I'm going to replace A with 3.9 and add B. So 3.6, multiply it, gives me 15.6 plus B. Subtract 15.6 from each side, and I will get B to equal negative 12. So I found my values of A and B. So therefore, my recurrence relation will be UN plus 1 equals 3.9 UN minus 12. Now you can stop here, or I'm going to continue on and do this again, but using the elimination method. So to solve it using the elimination method, we still have the same two initial equations, and I've just rewritten them out here. And I'm going to solve by elimination. So I'm going to eliminate my b's because I have the same number of them. So that means I'm going to subtract my equations. So 4a minus 3.6a gives me 0.4a. b minus b is 0. 3.6 minus 2.04 is going to give me 1.56. And then we'll divide both sides by 0.4. And I will get A equals 3.9. After I have that, I can use the same substitution that I did down here on this side. I just substitute it back into one of the equations. So I will pick the first one. So I'll go 4 times A is being 3.9 plus B equals 3.6. When we go 4 times 3.9, we get 15.6 plus B equals 3.6. We'll subtract the 15.6 from both sides, and we're going to get B equals negative 12. So you can see if they're matching up, our values are the same. Therefore, we have our values of A and B. So the recurrence relation is, so to get the next term, n plus 1, un plus 1, equals my A value 3.9 times my current term of un minus 12.